Objective 2. Solve for unknown exponents using properties of natural logarithms. So here's our table of the properties of natural logarithms. You might say that these look familiar. You are right. They're very similar to the properties of logs that we just learned. So natural log of a times b equals natural log of a plus natural log of b. Natural log of a divided by b equals natural log of a minus natural log of b. Natural log of a to the b. We can pull this exponent out and have b times the natural log of a. That's a mistake in your notes. Oh. Sorry about that. In your notes, get rid of this b. Just natural log of a. So b times the natural log of a. All right. Natural log of e to the x. All right, we're going to talk about this one. So, natural log of e to the x. Using this rule above, natural log of e to the x equals, we can pull this x out. This is just x times the natural log of e. And remember, natural log and e are inverses of each other. So e is the exponential. Natural log is like a log. So natural log of e is 1. So this is x times 1, which is just x. And it's the same idea in this last one. E to the natural log of x is just x. So in a way, this natural log and e, they cancel each other out. Let's work some examples of solving for unknown exponents using these properties. Alrighty. 4 to the x equals e to the x plus 2. Alright, y'all. So for these, one nice thing we can do is we can, in a sense, take the natural log of both sides. So we can write, not that, natural log of 4 to the x is going to be equal to natural log of e to the x plus 2. And now we can simplify. So properties of logs, we can take this exponent out to become x times the natural log of 4. Remember that the natural log of 4 is just going to be a number. You can use a calculator to find it. Now the natural log of e to the x plus 2. Okay, first thing, we take this whole exponent, we can pull it outside. So this is equal to x plus 2, don't forget your parentheses, times times the natural log of e. And remember what natural log of e is? That's just 1. So we're left with x times the natural log of 4 equals x plus 2. This guy equals 1, so x plus 2 times 1, which is just x plus 2. And I'm just going to not write with these parentheses anymore. All right. We're getting simpler. We're simplifying. We're solving for x. I'm going to subtract x from both sides. So we're going to have x times the natural log of 4 equals 2. Nope. Minus x equals 2. All right, y'all. Now, I said we're going to review some algebra skills. On the left-hand side, we're going to factor out an x. So if I factor an x out of this first term, I'm left with the natural log of 4. Remember that factoring is just the opposite of distributing. So instead of, multiplying by x, we're taking an x out of things. So the second term, all we have is an x, so all we're left with is a minus 1. And think this through. We factor this x out, so if I multiply this x back in, I should get what we had in the line above, which is true. So we're good. Equals 2. Okay, last step. We're going to divide both sides by natural log of 4 minus 1. These guys will cancel out, and you end up with x equals 2 divided by the natural log of 4 minus 1. And that's all for x. That is an exact value of x. So if you went ahead and typed in this as x, so did 4 to the 2 divided by natural log of 4 minus 1, that will be the same thing as e to the 2 over natural log of 4 minus 1 plus 2. And really the key here was just taking the natural log of both sides and then simplifying and using some algebra skills to solve for x. So let's do another example. 10 to the x plus 3 equals 2 times e to the 5 minus x. So first things first, we're going to take the natural log of both sides. And I'm actually going to scroll up just a touch if I can. Okay. So this ends up being the natural log of 10 to the x plus 3 equals the natural log. Make sure you take the natural log of everything on each side, okay? Don't split it up yet because we have to use our log rules to do that. So this is the natural log of 2 times e to the 5 minus x. Whole side, everything in it. Even if we had 2 plus e to the 5 minus x. Take the natural log of the entire thing. Okay, left-hand side, we can pull this exponent out and we get x plus 3 times the natural log of 10 equals, all right, y'all. We have two terms here. We have this 2 and we have this e to the 5 minus x. Rules of logs say that we can split this into two different logarithmic expressions. We can say that this is equal to the log of 2 plus, because they're being multiplied together, the natural log of e to the 5 minus x. All right. Now, what should we do next? All right, what I'm going to do next is just simplify this term right here, this very last term, this natural log of e to the 5 minus x. Now I'm going to leave everything else the same. So we got x plus 3, natural log of 10 equals natural log of 2 plus. All right, y'all. We're going to take this exponent out. So we end up with 5 minus x times the natural log of e. All right, and that natural log of e just equals 1. So we now have x plus 3 natural log of 10 equals natural log of 2 plus, I'm going to get rid of these parentheses now, 5 minus x. All right, now let's get all the x terms on one side. So what we're going to do is add x to both sides. So, I'm also going to distribute here. So I'm going to do x times natural log of 10 and then 3 times natural log of 10. So we're going to end up with x times, that'll be too many parentheses, x times the natural log of 10 plus 3 times the natural log of 10. And I'm going to add x to both sides, so I'm going to add x over here, and this is just equal to the natural log of 2 plus 5. So all I did from this step to this step was I added x to both sides, and I distributed this x plus 3 times natural log of 10. Now I'm going to move this term to the other side, so subtract it from both sides. So we get x times the natural log of 10 plus x equals natural log of 2 plus 5 plus 3 times the natural log of 10. All right, left-hand side, we got two terms added together, both have an x in it, so guess what? We're going to factor out an x. So we get x times the natural log of 10 plus 1 equals natural log of 2 plus 5. All right, and I'm also going to simplify this one right here, because this is 3 times natural log of 10, so I can actually put this 3 in as an exponent and get natural log of 10 cubed, which you might say is 1,000, and you're right. If you're good with that, you can go ahead and write 1,000. Okay, now I'm going to pause the video and erase the board and move this last line up so I have some more room to write and finish this simplification process, all right? Okay, so we had x times natural log of 10 plus 1 equals natural log of 2 plus 5 minus natural log of 10 cubed. So to get x by itself, we divide both sides by natural log of 10 plus 1. All right, so on the left-hand side, we just get x equals, yay, we finally got x by itself. Now, I'm going to kind of do some rearranging here. I'm going to say this is natural log of 2 minus the natural log of 1,000, plus 5, all over natural log of 10 plus 1. And we can simplify this even further, y'all. See this natural log of 2 minus natural log of 1,000? When you have two natural logs that are being subtracted, you divide what's inside these parentheses. I guess I should put this 2 in parentheses. So this is really natural log of 2 divided by 1,000 plus 5 all over natural log of 10 plus 1. And yes, we can simplify this 2 over 1,000 to 1 over 500. And that is the value of x. That was a long problem. But yes, the key really is just taking the natural log of both sides, using your laws of logs, and some algebra, some old algebra skills to solve for x. That's going to be it for this video, solving equations with exponents using natural logs. Email me if you have any questions.